Welcome to Unit 1 Video 4, Density. By the end of this video, you should understand that density is a ratio between mass and volume, and you should be able to perform density calculations. We're going to begin with a qualitative approach to density, then move on to a quantitative approach with calculations in a little bit. So qualitatively speaking, what is density? Density is a ratio between the mass and the volume of a substance. Since it's a ratio, you can think about it in terms of mass per unit volume, or mass for every 1 unit of volume. It's an intensive property, meaning it remains the same no matter how much of the substance you have. For instance, if I measure the density of this big gold bar here, I will find that the density is 19.30 grams per milliliter. If I cut that gold bar in half and measure the density of half of that gold bar, the density will still be 19.30 grams per milliliter. If I cut that gold bar in half again and measure the density of that now quarter of a gold bar, I will still find that its density is 19.30 grams per milliliter. In other words, no matter how much gold you will have 19.3 grams for every milliliter of gold that you have. And you might have noticed from that example that the units for density are generally grams per milliliter, or grams per cubic centimeter. As you may recall, milliliters and cubic centimeters are the same thing. Let's think about what this means. If we compare these two subway cars in terms of density, it's pretty clear that the first subway car is more densely packed than the second subway car because it has more people in it. But is this the only way for something to be more dense? Consider these two subway cars. We can also say that this subway car is more dense because there's more mass in the same volume. Let's try to compare this approach to density to the particle level. On the particle level, a higher density can mean a few different things. First, it might mean that you have more particles per unit volume. This would be like the first train situation, where you had more people in the same volume. So compare these two samples. They're both 1 liter, so they have equal volume, but in this sample, we have far more particles than in the sample on the left, making this sample on the right more dense than the sample on the left, because there's more mass in the same volume. Consider also this sample. I want to compare this sample to this sample here. Notice that in this sample here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 particles. In this sample we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 particles. Therefore, we have equal mass. But here on the right we have lower volume. This also results in a density that is greater. Therefore, this sample will have a greater density than this sample. Each of these cases looked at a situation where there were more particles in a given volume. We can also have higher density if we have heavier particles per unit volume. Compare these two samples. Here I've used larger circles to indicate more massive or heavier particles. Here we have the same volume, but we have much larger particles. Therefore, we have more mass, making the sample on the right more dense than the sample on the left. As you may have learned in previous science classes, we can qualitatively compare the density of substances by seeing which substances float on others. Less dense substances will float on more dense substances. Here, the least dense substances are at the top, where the most dense substances are at the bottom. Let's turn now to a quantitative approach to density, where we calculate density of substances. As you may know, the equation for density is density equals mass over volume. Again, density is a ratio, as indicated by our division sign, between mass and volume. We can abbreviate this as D equals M over V. Let's do an example together. We want to calculate the density of a block of aluminum with a volume of 15.0 milliliters and a mass of 40.5 grams. Let's start by writing our equation. Density equals mass over volume. Since we measure density in grams per milliliter, let's quickly check that our units are correct. We have grams for our mass and milliliters for our volume. If they weren't grams and milliliters, we would have to convert our units. So let's plug in our values. Our mass is 40.5 grams, and our volume is 15.0 milliliters. When we calculate an answer, we get 2.70 grams per milliliter. Notice I have to include this last zero since each of our measurements have 3 sig figs, so our answer should have 3 sig figs. Here are some problems for you to try on your own. Pause the video here and try these 4 problems. Be sure to write down your answers. Notice that not all of them ask you to calculate density, but rather perhaps mass or volume. Be sure to pay attention to units and make sure that you're rounding to the proper number of sig figs. When you come back, I'll reveal the solutions. Welcome back. Here are the answers. Take a minute to check yourself. If you got them all right, great. If not, we'll work on it more in class. That brings us to the end of the density video. Let's quickly review our goals. First, we learned to understand that density is a ratio between mass and volume. Then we learned how to perform some density calculation.